Hi everybody. In today's lecture we are going to study about Cayley Hamilton theorem. Okay, the statement of Cayley Hamilton theorem is every matrix satisfies its characteristic equation. That is, if A is a n cross n matrix, then A raised to n plus C1 A raised to n minus 1 plus C2 A raised to n minus 2 plus so on up to Cn into I is equal to 0. Okay, where A raised to n minus 1, these are n cross n matrices. Okay, and C1 C2 C3 are constants which should be a real number. Okay, in last lectures we have studied about a characteristic equation. Okay, we have find how to find characteristic equation. We have studied in our last lecture. Okay, you can find out in our last videos also. Okay, now we are going to study examples related to Cayley Hamilton theorem. So consider first example: verify Cayley Hamilton theorem and find A inverse of the matrix A is equal to, which is our square matrix of order 3. Okay, now Cayley Hamilton's statements state that every matrix satisfies its characteristic equation. Okay, so first we have to find the characteristic equation of matrix A. Okay, now to find characteristic of matrix A, we need to find A minus lambda I. Okay, because its characteristic equation definition is determinant of A minus lambda I is equal to 0. Now consider A minus lambda I, which is equal to matrix. Now here it is a matrix 2 minus 1 1. Here it is minus 1 2 minus 1 1 minus 1 2. Okay, this is our A matrix, and lambda I, where identity is of order 3, so it can be written as lambda 0 0 0 lambda 0 0 0 lambda. Okay, I have written the direct step of lambda I here. Okay, because identity matrix is of order 3, so diagonal entries of lambda I will be all lambda. Okay, now here A minus lambda I is equal to matrix. Here it can be written as 2 minus lambda. Only there are changes in diagonal entries, remaining entries will be as it is. So here it is minus 1 1. Next, for second row, here it is non-diagonal, it will be as it is minus 1. Here it is 2 minus lambda. Next it is minus 1 as it is. Next, here third row 1 as it is, minus 1 as it is, and last again it is 2 minus lambda. Okay, which is our A minus lambda I. Now determinant of characteristic equation is determinant of A minus lambda I is equal to 0, or it is also denoted as determinant of A minus lambda I. Okay, these are both notations of determinant of A minus lambda I. Now here it is equal to matrix. Now we have here it is a square matrix, it is a matrix. Now we have to find determinant of this matrix, so we do not in a straight line determinant. So it is 2 minus lambda minus 1 1. Okay, it is first row. Second row minus 1 2 minus lambda minus 1. Here it is 1 minus 1 2 minus lambda. Okay, this is our determinant. It is denoted of A minus lambda and it is equal to 0. Okay, now you have know the process to find the characteristic equation which we have studied in last lecture. Okay, in that we have considered a direct equation of lambda cube minus s1 lambda square plus s2 lambda minus determinant of A is equal to 0. Okay, equation we write it as equation 1. Okay, consider. Now here it is s1 is equal to sum of diagonals. S2 is equal to minors additions m11 plus m22 plus m33. Okay, now here S1 is equal to sum of diagonals, which gives here matrix A is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Now here diagonal entries are 2 plus 2 plus 2, so 2 plus 2 plus 2 is 6. So S1 is equal to 2 plus 2 plus 2 is equal to 6. Now here first we have to find minors m11. We write here a matrix, once again it is a matrix A is equal to, for rough calculation here it is rough, so it is a matrix 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, now to find m11 we first delete first row and first column, so our m11 is 2 minus 1 minus 1 2. Okay, so its calculation 2 minus 1 minus 1 2, so 2 2s are 4 minus 1 into minus 1 plus 1, so 4 minus 1, which is equal to 3. m22 is equal to determinant of, we have to delete second row and second column, here second column and second row. Okay, so 2 1 1 2 2 1 1 2, again it is 2 to the 4 minus 1, which is equal to 3. Okay, now m33 is equal to determinant of, here delete third row and third column, it will remain only 2 minus 1 minus 1 2 2 minus 1 minus 1 2, which is again 4 minus 1, which we have calculated, which is equal to 3. So S2 is equal to 3 plus 3 plus 3 is equal to 9. Okay, so this is our S2. Now mod of A, which means determinant of A, we have to find determinant of A is equal to, which gives 2 into determinant of, now here it is first row first column delete, so determinant of 2 minus 1 minus 1 2 2 minus 1 minus 1 2, here second it is minus of, here second entry is minus 1, so we write minus 1 into determinant of, now we delete first row, its position is 1 2, so we delete first row and second column, so remaining entries are minus 1 minus 1 minus 1 minus 1 1 2. Okay, and plus 1 into determinant of, now we have to delete first row and third column, so it will be minus 1 2 1 minus 1. Okay, now we take a calculation, it will be 2 into bracket 4 minus 1, which is minus 1 into minus 1 plus 1, which is 3. Okay, we write here direct calculation, minus 1 into minus, it is plus, here 1 we don't write, here calculation will be minus 1 into 2 is minus 2. Okay, we write here minus 2. Okay, minus 1 into 2 minus 2 minus 1 into, here minus 1 into 1 minus 1, which is minus 1, which gives minus 2 plus 1. Okay, it is a rough calculation, which is equal to minus 1, so here it is minus 1 plus 1 into bracket, we write here plus, minus 1 into minus 1, it is plus 1. Okay, and minus 2, which is equal to again minus 1. Okay, so here its last calculation is again minus 1, so 2 3s are 6 minus 1 plus minus minus 1, which gives 6 minus 4, 6 minus 2, which is equal to 4. So our determinant of A is equal to 4. Okay, so our characteristic equation will become, here we write equation 1 will becomes, so we put all values in equation 1. S1 is 6, so first it is lambda cube minus, so S1 lambda square, so S1 is equal to 6, so 6 lambda square, S2 value is 9 plus 9 lambda, and minus determinant of A is equal to 4, minus 4 equal to 0. Okay, now we have to find characteristic sorry, eigen value, we have to verify Cayley Hamilton theorem. Okay, for this we have to write its characteristic equation. So its characteristic equation is this, so we write it as equation second. Now statement of Cayley Hamilton theorem says that every matrix satisfies its characteristic equation. Okay, now we replace lambda by A, and where it is constant it is replaced by identity matrix. Okay, so our Cayley Hamilton theorem says that, so here to verify Cayley Hamilton theorem we put lambda is equal to A. So we get here lambda is equal to A, we can write it as A cube minus 6 lambda square plus, sorry, here 6A square, we have to replace lambda by A, plus 9A. Okay, minus, here it is constant. Okay, if we consider here 4, it is not a matrix. Okay, so we can't satisfy this equation. So to satisfy it we have to consider here constant and identity matrix. Okay, 4 into identity equal to 0, which is equation number 3. Now we have to check whether this equation is satisfied or not, so for that we have to find A cube, after that we have to find A square. Okay, and we have to put in equation number 3. Now to find A cube, so first we have to find A square. A square is equal to A into A, and our A matrix is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, we have to multiply again it by matrix A. 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. Okay, which gives us as, we write here, matrix multiplication, so we write here matrix multiplication as first row first column will be our first position, which is 2 into 2 4. We write here 2 into 2 4 plus or minus, we will check whether here it is minus 1 into minus 1 plus 1, which is equal to 4 plus 1. 1 into 1 is 1, which is equal to 4 plus 1 plus 1. Next, for second position, first row second column, A, which is A12. 2 into minus 1 is minus 2. Okay, 2 into minus 1 is minus 2. Minus 1 into 2, it is minus 2, and 1 into minus 1 is minus 1. Okay, again check 2 into minus 1, second column first element, second into second, which is minus 1 into 2, and last 1 into minus 1. Okay, which is our A12 position. For A13 we have multiplied first row by third column, again first into first, 2 into 2 is 2, minus 1 into minus 1 is plus 1, 1 into 2 is 2. Okay, now again second row first column will use A21, so minus 1 into 2 is minus 2, 2 into minus 1 is minus 2, minus 1 into 1 is minus 1. Okay, again second row second column, minus 1 into minus 1 is plus 1, 2 into 2 is 4, and again minus 1 into minus 1 is plus 1. Next, minus 1 into 1 is minus 1, 2 into minus 1 is minus 2, and minus 1 into 2 is minus 2. Okay, now next row, so for third row first column, which will 3 1 position, 1 into 2 2, minus 1 into minus 1 plus 1, 2 into 1 plus 2. Next, 1 into minus 1 minus 1, minus 1 into 2 minus 2, and 2 into minus 1 minus 2. Okay, second row, third row second column, which gives 3 2 position, and last row last column, 1 into 1 1, minus 1 into minus 1 plus 1, 2 into 2 4. Okay, which gives us as a matrix A square is equal to, which is our A square, which gives 4 plus 1 plus 1 is 6, minus 2 minus 2 minus 4 minus 1 minus 5, which is minus 5. Here 2 plus 2, 4 plus 1, 5. Now here minus 2 minus 2, minus 4, minus 1, minus 5. 1 plus 4, it is 6. Here it is minus 5. You make calculation now. Here it is 5. Here it is minus 5. Here it is 6. Okay. As our matrix A is also a symmetric matrix. If you see the position A12 is equal to A21, A13 is equal to A31, A32 is equal, A23 is equal to A32. Okay, it is symmetric matrix. So its square matrix is also symmetric. Okay, Aij is equal to Aji. Also its A cube is also symmetric matrix. Now to find A cube, you have to multiply A square into A. So our matrix is of the form, here A square is 6 minus 5, 5, minus 5, 6, minus 5, 5, minus 5, 6. Okay. Into matrix, our matrix A is 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. Okay. So A cube will be matrix. Again multiply 6 into 2, 12. Okay, 6 into 12. Minus 5 into minus 1 plus 5. Okay, and 5 into 5, 5 into 1, 5. Okay, which is first row, first column. Now first row, second column. 6 into minus 1 is minus 6. Minus 5 into 2 is minus 10. Okay, and 5 into minus 1 is minus 5. Next, third row, 6 into 1, 6. Minus 5 into 5, 1 is plus 5. 5 into 2 is 10. Okay. Okay, similarly, here it will be minus 5 into 2, minus 10. 6 into minus 1 is minus 6. Minus 5 into 1 is minus 5. Okay, here is second, minus 5 into minus 1 is 5, 6 into 2 is 12, and minus 5 into minus 1 is plus 5. Okay, now for second row, third column, minus 5 into 1, minus 5, 6 into minus 1, minus 6, and minus 5 into 2, minus 10. Okay, now last 5 into 2, 10, minus 5 into minus 1 is plus 5, 6 into 1 is 6. Next, 5 into minus 5, 1 is minus 5, minus 5 into 2 is minus 10, 6 into minus 1 is minus 6. And last, 5 into 1 is 5, minus 5 into minus 1 is plus 5, next 6 into 2 is 12. Okay, now this calculation is our matrix A cube is equal to matrix 5 plus 5 10 plus 12 is 22, minus 6 minus 5 11, 11 minus 10 which is minus 21. Okay, all terms are negative, we have to add 6 plus 5 10, 10 plus 6 plus 5 11, 11 plus 10 21. Okay, here it is also same, it is positive, which is 21. Similarly, here it is minus 21, it is 22, here it is again minus 21, it is plus 21, minus 21, 22. Okay, which is our matrix A cube. Now consider the characteristic equation of which we have to verify: A cube minus 6A square, A cube minus 6A square plus 9A minus 4I is equal to, now put the value of A cube is equal to 22 minus 21 22 minus 21 22 minus 21, it is again 21 minus 21 22 minus 6 into matrix A square is, we have find it here only, or we have written here also, A square it is 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6, okay, which is our A square. Next, plus 9 into A matrix. A matrix is here 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 minus 4i, okay, minus 4 into identity is 1 0 0 0 1 0 0 0 1, okay. Now we have to make multiplication, scalar multiplication, and after that we have to add addition or subtraction, which we have to take, okay. So first matrix is as it is, because here it is no scalar term outside first, so it is first as it is, a cube 22, here it is minus 21, it is 20, sorry, here it is 21, I have written wrongly, here it is 21, okay. So it is 21 minus 21 22 minus 21, it is 21 minus 21 22, okay. This is our first. We have to multiply 6 by inside, so it will be 6 6 are 36 minus 30, here plus 30, second row it is minus 30 36 minus 30 30 minus 30 36, okay. We have to multiply 9 inside, so it is 9 to the 18 minus 9 9, second row minus 9 18 minus 9 9 minus 9 18, and last we have to multiply, sorry, here it is minus into bracket, we have to multiply 4 inside, which is 4 0 0 0 4 0 0 0 4, okay. Now we make a calculation. Here it is equal to position calculation, okay. First position of all matrix, so 22 of first, here it is 36, outside sign is minus, so 22 minus 36 plus 18 minus 4, which is our first position. For second position it is minus 21, for first matrix minus plus 30, okay, or you can write minus into bracket minus 30. Anyway, here minus 21 minus plus 30, here plus 8 plus minus 9, and last it is 0 minus 0, okay. Now for first row last term, 21 minus 30 plus 9, okay, which is our first row complete. Now second row for same, minus 21 first, minus plus 30 plus minus 9, okay, and last it is 0 minus 0. Next 22 minus 36, okay, here it is 18 plus, okay, plus 18 minus 4, okay. Now last here it is minus 21, next it is minus 21 minus plus 30, and it is plus minus 9, and here it is 0 minus 0, here also it is minus 0, okay. Last row 21 minus 30 plus 9 minus 0, okay, minus 21 plus 30 is minus plus, and plus minus 9, and last 0, and for last it is 22 minus 36 plus 18 minus 4, okay. So if you do calculation for this, we get, first calculation is 22 plus 18 is 40, and minus 36 minus 4 is 40 also. It is plus 40 minus 40, which will be 0, okay. Here also 30 minus 21 minus 9, which is minus 30, plus 30 0. Okay, after checking calculation, all the entries in this matrix, if they are 0, then we can say that our Cayley Hamilton theorem is satisfied. Okay, this is our 0 matrix. So our here we get a cube minus 6a square plus 9a minus 4i is equal to 0. Hence, Cayley Hamilton theorem is verified. Theorem is verified. Okay, write it as equation number 4. Okay, now we have to find A inverse by using Cayley Hamilton theorem. Now to find A inverse, so here pre-multiply A inverse of equation 4. So we get A inverse into A cube, first term, minus constant 6 we write separate, A inverse into A square, plus 9 into bracket A inverse into A, minus 4 A inverse into I is equal to 0 into any matrix is 0. We write here 0, which will give us A inverse into A square. We can write here base is same, so power will be minus 1 plus 3, which gives A square. A inverse into A square is 6A. Here it is plus A inverse into A is identity matrix. We write here, and here minus 4A inverse is equal to 0. We write here in bracket also A into A inverse is equal to identity matrix. Okay, and A inverse into I is equal to A inverse. Okay, now we can find A inverse by using this. We shift this on right side, so here remain A square minus 6A plus 9I is equal to 4A inverse, or we can write 4A inverse is equal to A square minus 6A plus 9I. Okay, now put A square. A square is a matrix. Here we have find in above, it is as 2 or 6. Here it is 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6 is our A square. So we write here A square as 6 minus 5 5, which we have calculated in above example. Okay, minus 5, it is not necessary to do calculation again. Minus 5 6 minus 5 5 minus 5 6 minus 6 into A matrix. A matrix is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2 plus 9 into identity, which is 9 into 1 0 0 0 1 0 0 0 1. Okay, which gives as 6 minus 5 5 as it is, minus 5 6 minus 5 5 minus 5 6. We have to multiply 6 inside, so it gives 6 2s are 12 minus 6 6, first row. Second row minus 6 12 minus 6, third row 6 minus 6 12, and last row plus 9 0 0 0 9 0 0 0 9. Okay, so our calculation is, so first term 6, here it is minus, here it is 12 plus 9. Okay, it is first calculation. Second terms, seconds, minus 5 minus minus plus 6 plus 0. Next third position 5 minus 6 plus 0. Second row minus 5 minus minus plus 6, last 0. Next it is 6 minus 12 plus 9. Third position is minus 5 minus minus plus 6 plus 0. Last row it is 5 minus 6 plus 0 minus 5 plus 6 plus 0, and last it is 6 minus 12 plus 9. Okay, so our calculation is 6 plus 9 is 15 minus 12 is 3. Okay, 6 plus 9, 15 minus 12 is 3. Here minus 5 plus 6 is 1. 5 minus 6 is minus 1. Again it is minus 1. It is 3, 1. It is minus 1, 1. It is 3. Okay, which is our 4A inverse is equal to. So we have to find A inverse, which implies A inverse is equal to, here 4 is multiplied, it will be divide. It is scalar term, so we have to divide 1 upon 4 for each term, or you can write 1 upon 4 out of a bracket, out of a matrix. 3, 1, minus 1, minus 1, 3, 1, minus 1, 1, 3. Okay, which is our required answer. Okay, so this is the process for solving examples related to Cayley Hamilton theorem. Now for homework, you have to solve an example, verify Hamilton theorem and find A inverse of a matrix. A is equal to 2, 2, 1, 1, 3, 1, 1, 2, 2. Okay, for this first you have to find the characteristics equation of matrix A, and after that you have to verify Cayley Hamilton theorem, and after verifying Cayley Hamilton theorem you have to find A inverse by multiplying A inverse for a characteristic equation, which will gives A inverse of a matrix. Okay, so for today we will stop here. Thank you.